Hello, everyone. Nice to meet you today. Thank you for Hello Tomorrow to inviting me. I'm Bruno Paul Dauphin. I should see my screen shortly from Vinci Construction, and I will start with three numbers. Do you know what 1817 means? This is when Louis Vicat, the cement was invented in France by Louis Vicat in 1817. Another number is 6 billion. It will arrive 6 billion. This is 6 billion cubic meters of concrete used worldwide per year. Okay, that's quite a lot of concrete. And another percentage this time is 5%. 5%, this is the total CO2 greenhouse gas emission associated to the concrete poured each year. Okay, so we have an issue with the concrete, and let's talk about concrete. What is concrete? Concrete, it's mainly gravel and sand, okay, and water, 6% of water, but in fact, we only have 12% of Portland cement, this cement invented by Louis Vicat. This 12% represents 85% of the total CO2 of concrete. And you will understand later why. So this is an issue, but still the concrete is a great and probably the best material, the construction material, as long as we reduce its carbon footprint. We believe in Vinci Construction that the concrete will become the material for the future if we reduce its global footprint. And for this, we have three leverages. The first one is to optimize the use. The less concrete we use, the best it is. Okay, the best low carbon concrete is the concrete that we don't use. Let's make very clear on this. The second leverage is about the cement industry. The cement industry, they already commit to 30% CO2 reduction compared to 2019, which is good. And the main issue I told you about Portland cement, the cement, when you produce cement, you have the CO2 coming from the heating process, but also the CO2 coming from a chemical reaction. Limestone, you heat, you produce CO2. The good thing is that they tackle this, and I will come to this later. And finally, working on the concrete itself, it's possible to replace the clinker, the Portland cement, inside the concrete and to substitute, and that's the reason why in Vinci Construction we committed to 90% low-carbon concrete on all our construction sites worldwide by 2030. So going back to this and this carbon footprint, and you know that I will talk about low-carbon concrete. What are low-carbon concretes? Low-carbon concrete, it's easy. It's to substitute the Portland cement with additions, and all these additions have lower embodied carbon than concrete. As a result, you have low-carbon concrete. The more addition you have, low-carbon concrete, very low-carbon concrete, ultra-low-carbon concrete. But when we launched Exegi, this strategy 3 years ago, there was no definition of low-carbon concrete. That's why we created our own definition, and this is what we call the Exegi standards. And these standards, on the left, you have the embodied carbon. Let's be very precise. Let's not talk about percentage of reduction. Let's put kilo CO2 per cubic meter of concrete, which is a true, real numbers. And then on the top, you have the compressive strength of the concrete. By doing this, you take any concrete in the world, you have the embodied carbon, the compressive strength, you apply a specific standard. It's not a true definition for everyone, but this is the definition that we use within Vinci in order to measure our trajectory towards this 90% objective in 2030. Be free to use it. This is on our website. It's not protected. Use it, okay? So now, what are these additions? These additions, I told you to substitute the cement. I will tell you something that you will, or you can share it. Part of the low-carbon concrete, we've done this for many years without knowing that it was low-carbon. The suburb in Paris, at the beginning of the 20th centuries, they were using GGBS. The GGBS, it's a byproduct. It was a waste. I don't know, today we call it a byproduct from the steel industry. It means that when you produce steel, you produce GGBS, and this GBS can replace part or integrally the Portland cement. Okay? It's the same with fly ashes. Fly ashes, we've used it for many years. It comes from the power plants, and this is also a waste that was able to substitute the cement in concrete. The issue is that these two products, there will be less and less. It will be not enough to substitute integrally the Portland cement. And that's why we have to explore other solutions. And the good answer is it's still possible to do this without GGBS, without fly ashes. It's a mix of limestone filler and ultra-thin. And all these products are ultra-thin. It's calcined clay, metakaolin, silica fume. And all these products are available. And also very important, they are lower carbon than cement. And they are available all over the world. So the future of low-carbon concrete is really on this type of solution. So now be ready. Until now, this was very, very simple. Okay? This slide is a bit complex, but if you understand this slide, you fully understand the issue about low-carbon concrete. So there were two processes, the cement process and the concrete process. The cement process, you see, to produce clinker, you take the clay plus limestone, you heat, you have the CO2 generation, you have gypsum, and you put cement. This cement, in the cement plants, it's possible, so you have the clinker, and it's possible to have all this substitution at the cement plant itself, okay? And this is what we've done. For many years, we had this type of cement, which were already low carbon, and it's cheaper at that time. So we use it, it's low carbon cement. And the cement industry is now pushing the limit with other addition in order to be less and less, to have less and less embodied carbon inside. And even with disruptive solution, innovative solution, using this limestone and the calcined clay I was mentioning before. So it means that they are already in this direction towards this target zero. I will come back to this later on. The concrete itself, you understand this is a cement. The concrete, you take the cement, you take water, gravel, sands, you have the concrete. And this concrete, depending on the low carbon, very low carbon cement that you use, you have a low carbon concrete, and this is what is mainly used today, okay? But it's also possible at the concrete plant itself to put the additions, the slag, the fly ashes, the limestone filler, the metakaolin, and to produce engineering concrete or even performance concrete, which are compliant with the concrete standards, at least in France, and we push to have this compliant everywhere in the world because this is one of the solutions to expand and generalize low-carbon concretes. If you understand this slide, this is crystal clear for you. This is the solution today to massify. And all of this is compliance. But less clinker, less carbon, but poor early-age performance. And that's why when it will take longer setting times, it has an impact on planning because of the formwork removal time, and there is also an impact from when it's freezing in winter. This concrete is a bit lazy, we say. And that's why we, Vinci Construction, as a construction company, we have something to say, saying that concrete materials is good, but we also need, all the value chain of the construction needs to adapt its pouring methods, the way we design projects, and also the type of materials that we use is very important. And this is what we've done. This one is a ultra-low carbon concrete near Paris. And you see that the construction sites, they developed specific method in order to maintain the heat. They've developed specific heating formworks because this was the solution to use this type of product during winter. It works. This one is a pilot. This is our Formula One. But it's a demonstration that we, as a construction company, we can make it. And we can make it, and the lessons is that using low-carbon concrete, there is no impact. No impact on method, no impact on materials, no excuse to use low-carbon concrete. Go for it. Very low carbon, it's more difficult in vertical structure during winter, but if you heat the water, it works. Ultra low carbon, that's another story. We are very proud. The athlete village in the north of Paris for this summer is in this specific material, but that's really part of the innovation. And this is innovation, but it's not R&D. This is already, you see, all these projects, they are using low carbon, very low carbon, and even ultra low carbon. And you can see the variety of all the type of projects, civil engineering, buildings, tunnel segments. It's possible, and it's not only project in France, it's also international. Now, let's talk about the trajectory to target zero, okay? And we have this commitment, and we have our contribution. The first one, and I will talk about the efficiency in design and construction, okay? I told you, the less concrete we use, the cheaper it is, but also it's better for the environment. But more and more, we will have a mix between concrete, low-carbon concrete, and timbers. And this will be the solution to reach the thresholds imposed by the regulation, but also to reduce the impact of concrete. So very important, and this one is an example of ultra-low carbon with timbers in the athlete village in North Paris. The second one, so that was the responsibility of the construction. The second one is the responsibility of the concrete and cement industry. And once again, they've already started. When you look at Cemex in the UK, they invested in their cement plants in Rugby, where the rugby was invented, I guess, to eliminate fossil fuel in their heating production. Lafarge in Saint-Pierre-la-Cour with Holcim, they integrate the activated clay solution in order to reduce the footprint of their carbon. And it's the same with Vicat. In Xeuillet, they also invested in this calcined clay production. And another project with Heidelberg, once again in France, you will see is a lab for that, is to transform and reduce by 27% its embodied carbon. So they are there, and they want to make this move, which is good. The second thing is, you see in purple, this is the big gap. And this big gap is the carbon capture and storage. And once again, we see this starting in Norway, Heidelberg Materials. They already invested, and I understand that by the end of this year, we will have this carbon capture, so zero carbon cement available coming from this cement industry. And closer to us in France, in Limbre, Equiom, in partnership with Air Liquide, they also invested money into this carbon capture unit, carbon capture sequestration unit. So this is promising. And just to say, I will not cover all the points. I only have 17 minutes. But just to say that if the construction, cement and concrete industry is working together, we can make it. Now, let's talk about the startup. We have a lot of new players, new entrants, some of them with a very long maturity, like our partner Ecosem, for example. But you have all these partners, Geoclay, Ecosem, Forterra, that develop new materials. These new materials are not necessarily compliant to the French concrete standard, to the concrete standards. So we have to work with them and making sure that they can express themselves. And that's very important. They are agile and they push cement industry and even the construction to act differently. We also have the alkali activated binders, and Ecosem, we've developed together this solution for the athlete village in North Paris. We have a Neolith, well known for the waste fossilization. We have all the solutions to enhance the curing of concrete and even the self-healing concrete. All of this is very detailed in the Hello Tomorrow report done with Leonard, explaining all of this. And I'm going back to this is the the first slide was to explain the concrete and cement. This one is very, very important. It's not from me, you have the source of this document, but this is exactly what we need to generalize low-carbon concrete worldwide. It's building a low-carbon concrete business ecosystem. And this low-carbon concrete is making sure that the suppliers, the concrete industry, the cement industry, they work together with the customers, Vinci and all the other construction company. We, Vinci, to talk with our own customers, the big project owners, okay? We need to work with the startup because they have a lot of ideas, a lot of energy, and a lot of creativity. So let's work with them. We need to work with the public bodies about the environmental regulation. It helps also. We work with the EPFL, universities of Toulouse, and lots of projects, and we need to finance PhD. This is important, the R&D, and obviously, mainly the startup, they need investors. So this build ecosystem, I can tell you, it works. It works because in France today, in the building and civil engineering in France, we have already reached 50% low-carbon concrete in 2023, according to our EXEGI standards I mentioned before. And this is just because we started this ecosystem, building in this ecosystem 3 years ago. And I can tell you that if it works in France, thanks to this regulation, the environmental regulation 2020, it's really possible to extend it, to adapt this ecosystem outside of France by working closely with the cement industry, with the concrete industry, with the startup, with our clients. And by doing this, I'm confident that we will be at 90% low carbon concrete by 2030 and hopefully neutral carbon by 2050. Thank you very much. Happy to answer any of your questions.
Thank you so much, Bruno. That was absolutely fascinating. Quick, speedy presentation about these areas that hopefully we can dive into a little bit more in the Q&A. I can see some questions are coming through. That's awesome. Please make sure to type them in now. I've got a question of my own to kick us off, but I'll be going off your Slido questions after that. So, Bruno, you've been talking about this idea of an effective ecosystem, as it were, to get us to that low-carbon future. But what would you say that looks like in reality? I mean, what do we actually have to do to get there? Who needs to do what? What should businesses be doing? What should government be doing? What should media be doing? You know, we know from, I mean, even looking at Hello Tomorrow and building deep tech ecosystems, it's a real concerted effort to make this happen.
Thank you for asking this question, because this is really the key. The key is trust and confidence all across the value chain. Today, and maybe not today, yesterday, we were working in silos, okay? You still have the relationship clients, suppliers. If we connect, not breaking the silos, but connecting the silos, making sure that we share the same objective of decarbonization, because we believe that concrete is important. Making sure that we work in partnership, that we share the success, that we share the benefits, that we work together, including the startup. And I will give you a simple example. The standards, the concrete standards. Today, these standards were made 20 years ago, even more, and based purely on Portland cement. It's a new world today. We use only 30% sometimes of Portland cement in concrete, but the standard are still made on 100% Portland cement. So we need to change the habits, to rethink and reinvent. And once again, it's just talking together in trust, confidence that we can make the difference.
And actually, we've got a question referring to Portland cement, asking what are the methods of making Portland cement carbon-free? Because this, does remain the primary carbon source with the low-carbon cement plans proposed.
The solution, and until 2030, what is important is to go until the bones. Let's decarbonate as much as we can in the construction industry, the cement concrete industry, but we will still stay at 100, 120 kilo CO2 per cubic meters. And the solution is the carbon capture. The carbon capture is very expensive. We expect clinker to increase in terms of price, and that's also the reason why we plan to use less clinker. Technically, we know the oil and gas business, they are used to this technology, and we need to adapt. This morning, I was with a startup called Montel, based in the US, and they developed solution to capture CO2, mainly for industry. Typically, this is this type of solutions that we need to push. It's not my responsibility as a construction company, but obviously we will value the cement industry, all the industry trying to capture their CO2 at the source.
Well, and that's interesting. So we've got the next question here is about carbon capture and saying carbon capture in cement production comes with high capex and opex, right? So is that ever going to be competitive, or is it better to focus fully on alternative binders?
Very good question. I tell you, yes, it's very expensive. It's 100 millions of investment for this. We have in Europe, you have innovation funds and investment fund to really support this transition, and we will make it. But in the construction, we don't want concrete to be more expensive. Yeah. So I tell you, we've developed the solution with limestone filler. Limestone filler, 50% limestone filler. Calcined clay, it's 15% calcined clay, 50 limestone filler, 15% calcined clay, and the rest of clinker. By doing this, you much less clinker. So even if this clinker is more expensive, I will have less exposure for my concrete recipe. And if this is even lower carbon, instead of being low carbon, I will be ultra low carbon. So I will be happy. But this is a big, for many years, there were a very limited change, a limited move in the concrete and cement industry. In the last 5 years, there is a revolution. And I'm very optimistic about this, as long as we all work together, looking at the same direction.
We've got time for a very quick final question, if you're quick to answer. What's your view on scalability of some of the new technologies being used, bio-based materials, electrochemical-based cement production?
You see that in France, we have already reached 50% low-carbon concrete, so massively we can do it. I'm quite confident that we will be there before 2030. And the issue is about the supply chain. Yeah. All this substitution material, we are lucky in France because the system is in place, and we have to do the same. An example, and I finish with this, metakaolin. The metakaolin, we believe that this is a great product. It's calcined clay, very reactive, but today it's not done for the construction grade. So we are working with the metakaolin industry in order to propose grade adapted to the construction. And when I say grade for the construction, it's cheaper, and making sure that we have the good performance, because the key, and I will finish with this, XEG is low carbon, but also high quality. We can't neglect quality when we build infrastructure for 50 years or 100 years.
Amazing. Bruno, please join me in giving Bruno a huge round of applause and your thanks.
Thank you very much.